My name is Keith Norbie. I'm with SolidFire, and we're here again at the vBrownbag sessions at VMworld 2014. And today we want to talk about solving for VDI storage at scale. I've got a very special guest with me. He works with me at SolidFire. And this topic is something that'll be pretty cool to jump into, because as we've looked for solutions into VDI, storage is the #1 thing that people are trying to solve for. And solving for it at a couple of desktops, or tens of desktops, or hundreds of desktops, is one sort of part of the process to fix people's environments. But doing that in the large-scale environments is a whole other order of magnitude, and it's a lot of good conversational things to get into, a lot of attributes to, define, and ultimately trying to solve for how you can accomplish that. We've seen that as being the big barrier of these thousands and tens of thousands of VDI desktop deployments based on just raw scale and how you get underway with that. So with that, very special guest again, Aaron Patton. And with that, Aaron, why don't you introduce yourself?
Yeah, so Aaron Patton, VDI architect at SolidFire. And even though we both work for SolidFire, we're kind of going to take those hats off for most of this presentation and kind of talk a little bit at a very high level about some of the design points that you got to think about when you're doing VDI at scale, right? So some of the stuff we want to break down are things around scale. What do you do with performance? How do you deal with automation at scale? What to do about failure domains, and also capacity requirements when you're doing big VDI deployments. So starting with, scaling, right? So every virtual desktop deployment starts small, right? Everyone does a POC, or they do a pilot where they spin up a couple of desktops and they're testing functionality, right? So these things generally work fairly well from a performance perspective when they're small, right? But when you scale something up from 300 to 3,000 desktops, if you don't design it well, it's going to blow up, right? So part of the reason that a lot of VDI deployments blow up is because of the storage infrastructure. I think something like 78% of VDI deployments never get out of POC. So the primary technical reason is storage problems, right? And a lot of what dictates your storage performance thresholds are whether or not you pick a scale-up or a scale-out architecture. Both are fine, depending on how you want to implement, but setting your course on the big decisions about how you're going to architect your storage charts the course for the rest of the deployment. And also, you also want to make sure that if you're starting from a small thing that you're going to kind of dollar cost average into, right? So if you buy a smaller configuration with the plans to expand it out over time, you need to make sure that you're taking into account what your actual scale points are going to be further on in the infrastructure, and making sure that you've got all that stuff nailed down. And this is especially important when you're going overseas, right? Because your power and cooling costs can be much more expensive in places like Singapore than they are here. So there's a lot more focus on what your actual rack footprint looks like and how much power it takes to run that than it would be here, right? So,
yeah,
architectures that would have worked here fine in the States may be broken for a service provider in Singapore, right?
Yeah.
So moving along to IOPS. I hate this concept of average IOPS, right? So in every sizing discussion we have, it's like, okay, trying to break down, okay, what's the size of the IOPS? What's the read-write ratio? And then, of course, as soon as you figure out what that is, you put a table stake in the ground, and then that's what you have to design around. And intrinsically, it's broken as soon as you implement it, because there is no average I/O, right? The I/O patterns for virtual desktops, they're all over the place, right? You move from these large sequential reads during boots into kind of this write-heavy random workload and steady state, and those I/O patterns, you can't design for both at the same time with a traditional storage array. You're going to have to pick something and then live with it.
Yeah, I think that's a good point, because it's not just about capacity in a VDI deployment, especially at scale. It's about how to deal with it without having to create islands. Mm-hmm. And it's about the user getting the high definition user experience. And the problem is that one user starts to establish a baseline today, and they start using applications differently or data differently tomorrow. And if you've designed for one thing today, you almost box yourself into the limitation of their user experience going forward. So you have to be able to have adaptability in your design, whether it's a building block architecture or however you're doing that for scale.
Yeah, the ability to flex is important, especially if you're doing desktop management tasks like recomposes and things like that. That looks drastically different than a login VSI workload that you might use to kind of make sure that your initial deployment is okay. And so there's other flash type technologies that have helped this. Stuff that's like built into View like CBRC, things on the array side like array fast cache like with the VNX, or other things like Infinia or Atlantis, or other things that can kind of stick in between your endpoints and make sure that they get the kind of performance that they need.
Right.
All of those are great. You know, some of them add more complexity than others, some are better fits than others, but you know, there are ways to kind of brute force your way through that. And kind of VDI is a pathological workload. And the reason I love putting that in there, because I was talking to a customer one time, and he was kind of did a demo, and we pulled everything up, did a couple of IO tests, and he's like, that is a pathological workload, and I will not allow that on my storage array with my databases. So
I can vouch. I am a pathological user. There's no question about that.
Yeah. So we had to find out.
Use your VDI environment.
So for that particular customer, we had to figure out, so how do we fence this off from everything else so that everyone's happy, right?
Yeah.
And then those type of implementation decisions that you make drastically impact your workload, right? And then how you manage it, right? You need to have your desktop team in part of this, right? So if you, as a server admin or a storage admin, are making all the decisions on the VDI infrastructure, you're going to make the wrong call. I'm sorry. You just don't understand how those desktops are used, how they're managed, and lack of knowledge in that space has blown up more than one POC that I've been involved with.
Yep.
So again, storage tiering technologies can work, but they're highly, highly dependent on locality of reference. If you have a workload that is very large compared to your top tier or the cache that's spacing that, you run a lot of problems with cache drain and not being able to deal with that very effectively, right? And then other workloads that might be running that happen to be on a lower tier of storage or something like that could blow things up. I've run into a couple customers where they had backups that ran at night that cratered the desktop performance for their India desktop users who were, off scale from everyone else, but their North America users were just fine.
Right.
So a lot of those type of decisions, and again, being aware of how the environment's used is key.
Yeah, it's kind of funny because in the small and medium business VDI, you'll find a lot of localities in one time zone region, but at large scale, there's probably a high probability that you'll have a 7x24 follow the sun issue, and therefore workloads are never static to one time zone.
Yeah, and so communication, again, across all the business units involved is key. Sometimes it's really difficult because of different customers and silos and such, but it is important if you want a fully functional system, especially at scale when we're talking about thousands of endpoints and coordinating workloads and things like that. So AFAs are a decent way to handle this, right? So with all flash arrays, you still have to be aware of other workloads. So unless your array gives you the ability to carve out QoS effectively, then you effectively have just made a faster box, and it's still first come, first serve for any I/O that's getting served, right? So if you have very aggressive disk-bound workloads that are running, you still are going to have performance problems at some point as you scale up.
And I think it's always a design choice. It's not impossible to design for that. It's just there's just different offsets that you have to work with. But I think the argument here is it all flash or is it hybrid? And flash is non-negotiable. If you're doing any kind of VDI at scale or not, you have to have flash somewhere in the environment, just based on the nature of its application for the workload. At scale, AFA has really come to the point now where you're not really looking at hybridity or trying to get any disk and flash solutions at scale, because the architectures make so much more sense, especially with inline efficiencies. You may as well just go AFA. Yeah,
and as the cost curve for SSD, continues to march on, you'll see the use of flash, move from more of a tactical thing to kind of a flash everywhere approach. So EMC will tell you that there's flash everywhere right now, but there's still a whole lot of spinning rust backing up a lot of these architectures. When we talk about management, there's a lot of potential management points in a large-scale solution, right? Especially if you're doing like a pod-based architecture, right? So I've got 1,000 users and I buy some stuff for this. Another 1,000, I buy some stuff for this. Another 1,000, I buy some stuff for this. And that is a way to scale effectively, but it also creates a lot of management pain if you don't have a way to kind of roll these things up effectively, right? So that's something to be aware of as you kind of buy things out. Plan out how you want to manage this at the end.
Yeah.
Right. So.
Well, and isn't it kind of funny because a lot of large-scale places will say, I want to hit the go button now. They'll start with a small pilot, and then they'll say, all right, now I want to go mass. And you have to make sure that you have design parameters so you're not just taking small building blocks. Right. And you can either do that with separate islands of resources, or you can try to find ways to collapse that or be able to use that with a scalable solution that would fit the bill.
Yeah, and especially if you're like if you're a IT shop that wants to do like desktops as a service internally, like on-prem DAS, or if you just want to offer desktops to a line of business, you know, the ability to have a REST-based API is also important, right? You want to build some type of user self-service portal around these things. So, you know, when you're looking at array choices, you know, make sure that you're looking for something that you can manage easily at scale. So, you know, kind of SMIS and stuff like that. Yeah, they'll get you some, you know, but that's really not what you need when you want to be able to dynamically and programmatically carve things out in your infrastructure, right? You know, we talk about pools of compute and pools of network, and, you know, but now we want to do pools of storage. If you want to have a software-defined data center, right, you got to be able to programmatically carve that thing up.
Yeah, desktop workloads for sure, as we see here, as they have their EUC business unit in with the software-defined data center, it is just an extension of the usage of the resources that are mixed in the same workloads as tier 1 apps and everything else.
Right.
So it's all software definable into layers of, you know, say gold, silver, and bronze users, and the question is how can you build you know, automation, not just up at the desktop creation level or any kind of compose for images or recompose or link clones, but then down to the resources as well to understand how that orchestration can play out at very large scale.
Right, and then, you know, at the management scale, you know, having fully functional vCenter plugins as a very basic thing is a must-have, right? Okay. So failure domains, you know, how big is your bucket? You know where your hard and soft limits are. So Ray Heffer here has got a good little site that shows you, especially as Vue is concerned, you know, what your maximums are. Make sure you design your system utilization appropriately, right? You don't want to run your systems up to 70, 80% and then have something tip over as soon as you have a shelf, you know, or a disk fail or something like that. Protection considerations, if you're using a more traditional RAID sense, like if you're, you got to figure out what type of RAID type you're going to use, how big pools or aggregates or whatever you're going to be should be, so that you understand, like, if one of those were to fail, what the impact to your users would be. And then from a control perspective, or capacity control, like if you're doing the Vue thing, try to leverage link clones because they'll help you out, especially on a capacity utilization. And you can use SE Sparse Disk to help you control that very well. Then they've got space reclamation that you can do, right? You got to be a little bit aware of what happens when you turn that on because there is a performance impact with it, you know, but be aware of that. And then, you know, look for stuff like inline compression, dedupe, then provisioning. These things help you be more effective with the capacity that you bought. So, you know, putting the SolidFire hat back on now at the end of this, right, you know, I would say that we offer a pretty compelling solution for all of this. You know, we scale very well with a scale-out system that we have, where we can scale from 4 to 100 nodes, very large capacity and I/O performance. We can do very predictable performance by guaranteeing performance minimums with QoS. We manage very well with a fully REST-based API that we can integrate into any of the cloud service provider models with. We have a self-healing architecture, which just means we recover very quickly from failures. And then we can control all these capacity requirements with always inline efficiencies. So, I mean, with that, I think we're done, sir.
Excellent. Well, again, thank you to the vBrownbag crew for providing a community plugin for us to talk about at-scale VDI environments with storage. This is at VMworld 2014, and have a great rest of the show.
Thank you.